Hi, welcome to another Algebra 1 video. In this video we're looking at section 3.3, which is about function notation. In this video we will learn about the function notation, we will learn how to evaluate a function for given x values, we will learn how to solve for an independent variable when given the function's value, and finally we will also learn how to graph a linear function. So what is the function notation? The function notation is a notation of a function that is used to name them. Normally we write functions without the function notation by using the variable y, so you could come up with a linear equation y equals to 2x plus 0.5. So this is normally what we write functions like, where y is our dependent variable and our x is the independent variable. Another function that we could write could be y equals to negative x plus 1. So here we have y for both of these functions, and if we want to create a distinction we can use the function notation to do that. So the function y equals to 2x plus 0.5 could be represented as f of x, or the function of x. So you read that as f of x. So we could rewrite this first function y equals to 2x plus 0.5 as f of x equals to 2x plus 0.5, where f of x is equal to your dependent variable, which is also the y part of the equation. So f of x and y are the same thing. You could also name the second function f of x, but let's call it h of x. So this function will be the function of h. So h of x would equal negative x plus 1. Now let's learn how to evaluate functions for given x values. In a question where you have to evaluate functions, you may be given a function with the function notation. So in this question we're given f of x. The function f is equal to 2x minus 1. And we will also be given some functions that we have to evaluate. So in this question we're being asked to evaluate f of x for the x value of 2, which can be represented in the function notation as f of 2. So f of 2 in this case would be 2x minus 1, so we plug in the 2, minus 1. 2 times 2 is 4 minus 1, and we get that f of 2 is equal to 3, as 4 minus 1 is 3. So here we're given that x is negative 0.5 and we have to evaluate f of negative 0.5. So what is the y value, or the f of negative 0.5 when you plug in negative 0.5 for x? Well, you can plug in that value for x and we get 2 times negative 0.5 minus 1. 2 times negative 0.5 is negative 1, and we carry down the negative 1 there. So negative 1 minus 1 is negative 2. So our value for f of negative 0.5 is equal to negative 2. And you can write the f values here if you want as you do your work, but it's not necessary, but make sure to put in the last step that you've solved. Let's look at f of 3/2. In this question we have a fraction and we have to find the value of f of 3 over 2 for x equaling 3 over 2. So again we can plug in 3 over 2 for the x, minus 1. So here I can see that I can cancel out the 2's, which leaves us with 3 minus 1. So f of 3 over 2 would equal 3 minus 1, which is simply 2. So this problem was about evaluating functions. We were given some x values like 2, negative 1/2, and 3/2, which are x values, and then we plugged in these x values into our function, which is f of x equals 2x minus 1. So we plugged in the 2 for x, we plugged in the negative half for x, and a 3 over 2 for the x. And we evaluated for the function to get the f of x value. So here we got f of 2, f of negative 0.5, and f of 3/2. In question 2 we're given the function that f of x equals to negative x over 3 plus 5. And we're asked to evaluate the function for x equaling to 1, 0, and 3. Well, in this case we're putting the x value into the function, so we're going to get negative 1 over 3, so I've plugged in the 1 into the x, and the plus 5, which will equal to negative 1 over 3, and then we have to make a common denominator for that 5, so we can add negative 1/3 and 5. So we can multiply the top and bottom of the 5 with 3 over 3, so this equals to 1, so we're not changing the equation at all, and this will equal to negative 1 over 3 plus 15 over 3, and that equals to 14 over 3. So when x equals to 1, f of 1 equals to 14 over 3. Now let's solve f of 0. So we're plugging in 0 for our x value. So negative times 0 over 3 plus 5. Negative 0 over 3 is simply 0, so we're left with 5. So our f of 0 would equal to 5. Finally, we're given f of 3. So our x value would be 3, and we plug that into the function. So that would be negative 3 over 3 plus 5. The negative 3 over 3 equals to negative 1, as the 3's cancel out. plus the 5. So our f of 3 would equal to 4, as negative 1 plus 5 is like 5 minus 1, which is 4. Now how to solve for x if you're given f of x in a function. So in these type of questions, we're given the value for the f of some number or function of some number, and we're asked to find the x value. So in the first question, we're given that the function h of x equals to 2x plus 5. So this time we have a function h, not f, and we're given that the value for h of x equals to 5, and we don't know for what x value it equals to 5. We're also given h of x equals to negative 10, so this must be for a different x value. And finally, we're given h of x equals to 3, so this x must be another value as well. So let's look at h of x equals to 5. So what we do is plug in the value for the h of x into the h of x in the original function. So we get 5 equals to 2x plus 5. So I can subtract 5 from each side of the equation, and we're left with 0 equals to 2x, and therefore x equals to 0. So h of x equals to 5 when x equals to 0, or h of 0 equals to 5. That's another way of writing it. We're given that h of x equals to negative 10. So again, I can replace the h of x in the function with negative 10. So negative 10 equals to 2x plus 5. I can subtract 5 from each side of the equation, and that brings us with 2x equals to negative 10 minus 5, which is negative 15. And now I can divide each side of the equation with 2. So negative 15 over 2 would equal negative 7.5. So x equals to negative 7.5. Or it could also mean h of negative 7.5 equals to negative 10. We're also given h of x equals to 3. So again, we replace the h of x with 3. So 3 equals to 2x plus 5. We subtract 5 from each side of the equation. This cancels out, and we're left with 3 minus 5, which is negative 2, equals to 2x. And we can divide each side by 2. This cancels out, and we get x equals to negative 1. So this is the answer for this equation. And you can also write this as h of negative 1 equals to 3. Let's do one last one for this type of problem. We're given that g of x equals to 2 times 3x plus 5 in the distributive form, minus 1. So we know that g of x equals to 99 for some value of x, and we don't know what that value is. So I can set the g of x equal to 99, as g of x is given as 99. So 99 would equal 2 times 3x plus 5 minus 1. And we just solve this like a linear equation. So I can add 1 on each side of the equation. So this cancels out, and we get 100 equals to 2 times 3x plus 5. And I can divide each side of the equation with 2. So here I get 50 equals to 3x plus 5. And I can subtract 5 from each side. This cancels out, and we get 45 here equals to 3x. And we can divide each side of the equation with 3. So we get 45 over 3 equals to 3x over 3. So this cancels out, and 45 over 3 will equal to 15. So x would equal to 15. And you can also say that g of 15 would equal to 99. Now let's graph a linear function that is written in a function notation. We're asked to graph the function k of x equals to negative x plus 2. So the name of this function would be with the function k, because we have k of x. So in order to graph this, we have to find some points using a table set. So here's my table set, where I will pick the values for x, in which I will find the k of x. So let's take the values of x from negative 4 and end it at 2. And this middle box will represent as we do our work to find the value for k of x. So our function is negative x plus 2. So we plug in that negative 4 plus 2. Negative times negative 4 is 4, and 4 plus 2 is 6. And then we plug in negative 3, negative 2, negative 1, 0. We plug in 1. And finally plug in 2 for x. Now let's solve all of these functions for k of x. So negative times negative 3 is 3, plus 2, which is going to be 5. Negative times negative 2 is 2, plus 2, which is 4. Negative times negative 1, which is positive 1, plus 2 will give us 3. So you can see the pattern, we're just decreasing by 1 as we increase by x. So our next one is going to be 2, 1, and 0. Our first point is going to be negative 4, 6. So negative 4 is here, and our 6 will be at this point. Negative 3, 5 would be from here, negative 5, and then we do plus 5 along the k of x axis. So negative 3, 5 is over here. And the next point, negative 2, 4, so negative 2 is here. Plus 4 in the y-axis, we'll put our point here. And negative 1, 3 would be at negative 1 along the x-axis, plus 3 on the y-axis, which will be here. And we get 0, 2, which is simply here along the y-axis. And we have 1, 1, which is over here. And we have 2, 0, so We drag 2 on the x-axis and 0 for the k of x. So this is what our graph would look like. It's a straight line, which tells us that it's a linear function. And from the table we can also see that k of x decreases by a value of 1 for every increase in the x by a value of 1, because we have a constant change in k of x for a constant change in x. And this is it for section 3.3. I hope you understand the function notation now and how you can use it to find values of the independent variable or the dependent variable, and also how to graph using the function notation, just like in this case we solved. Leave a like if you found this video helpful and subscribe for more videos in the future. And I'll see you in the next video. Thanks for watching.